Hey, it's Professor Dave. Let's talk about scientific notation and dimensional analysis.
He knows a lot about the science stuff. Professor Dave explains.
Humans like to count things. In the first civilizations, we had to count in order to trade goods with one another. Because we have 10 fingers, we based our counting on a system of 10. If we count apples, we can get to 9, but if we add one more, we put a 1 in the tens place and then start building up the units place again. There's a hundreds place, thousands, and so forth. Each time we reach the next factor of 10, we add a digit. But what if we want to talk about a really big number, like the number of molecules in this glass of water, or the number of stars in the universe? It's going to get tedious very quickly to have to write numbers with dozens of digits. We need a way to abbreviate very large and very small numbers. That way is called scientific notation. A number written in scientific notation will always consist of a single digit followed by a decimal point, and then some other numbers depending on how many sig figs are in the value. That number is multiplied by 10, which is raised to an exponent. What this represents is the magnitude of the number. 10 squared means 10 times 10, which is 100. So 1.42 times 10 to the second is 142. We can get that by moving the decimal to the right twice. 10 to the sixth, or a 1 with 6 zeros, is a million. So 5 times 10 to the sixth is 5 million. We can get this by moving the decimal over 6 times, adding zeros if we need to. We can also discuss very tiny numbers this way. 10 to the negative second means 1 over 10 squared, or 1/100th. So 3.5 times 10 to the negative 2 is 0.035. We can get this by moving the decimal 2 places to the left. And 8 times 10 to the negative 9 will be this number once we move the decimal 9 times. This is useful because now we don't need inches and feet and miles. We can scientific notation.